Kes denggi seluruh negara meningkat 20.7% kepada 33,367 kes setakat minggu.
Nyamuk Aedes berwolbachia akan terus dilepaskan secara berperingkat di lokaliti yang dikenal pasti mencatatkan peningkatan kes demam denggi. Menteri Kesihatan Dr. Zaliha Mustafa berkata, sejak
kes denggi seluruh negara meningkat 27% kepada 33,367 kes setakat semalam berbanding 27,640 kes bagi tempoh sama tahun lepas. Menteri Kesihatan Datuk Seri Dr. Zulkifli Ahmad berkata situasi di Sabah lebih membimbangkan apabila negeri itu mencatatkan lonjakan drastik sebanyak 50.4%.
Assalamualaikum and a very good day to the respected panels and everyone watching this presentation. My name is Nurazrenn Fatin binti Abdul Razak, and today I will be presenting my research entitled Spatial Distributions of Dengue Cases based on land surface temperature and land use land cover using GIS and remote sensing techniques in Pulau Pinang. This research was conducted under the supervision of Puan Suhaila binti Hashim. Dengue is one of the fastest growing mosquito-borne diseases worldwide, with more than 14.6 million reported cases and approximately 12,000 deaths in 2024, affecting over 100 countries. In Malaysia, dengue continues to pose a major public health challenge due to rapid urbanization and environmental changes that favor mosquito breeding. Pulau Pinang was selected as the study area because it is one of the Malaysia's most urbanized states, where dense residential development and increasing temperatures may contribute to dengue transmissions. Understanding where dengue cases occur and the environmental conditions surrounding them is essential for improving disease prevention and control. This study focuses on two important environmental factors: land surface temperature, or LST, and land use land cover, also known as LULC. Temperature directly affects the life cycles of the Aedes mosquito by influencing its breeding, survival, biting frequency, and virus replication. Land surface temperature provides a better representation of the actual thermal conditions experienced by mosquitoes than air temperature. Meanwhile, land use land cover determines the availability of mosquito breeding habitats. Built-up and residential areas usually have higher population densities and more artificial water containers, making them favorable environments for dengue transmission. Therefore, by combining LST and LULC using GIS, this study provides a more comprehensive understanding of the environmental factors associated with dengue distributions. The aim of this research is to investigate the spatial distributions of dengue cases in Pulau Pinang by identifying clustering patterns using global Moran's eye and visualizing their relationship with land surface temperature and land use land cover. To achieve this aim, two objectives were established, which is the first objective is to identify spatial patterns of dengue cases distributions using global Moran's eye. The second objective is to visualize the geographic relationship between dengue cases clusters, land surface temperature, and land cover types using GIS techniques. Next is methodology. The methodology consists of four phases. Phase 1 involved collecting dengue case location data together with Landsat 8 satellite imagery obtained from USGS and Google Earth Engine. In Phase 2, land surface temperature was generated using Google Earth Engine, while land use land cover maps are produced throughout layer stacking in AirDAS imaging, followed by image classifications in ArcGIS probe. Phase 3 involves spatial analysis using global Moran's eye to identify clustering patterns, followed by spatial overlay analysis to examine the relationship between dengue cases, LST, and LULC. Finally, the outputs included that spatial clustering pattern, land surface temperature map, land use land cover map, and the spatial relationship between dengue distributions and environmental factors. Next is our first result for our first objective. The first objective was achieved using global Moran's eye. The analysis produced a Moran's eye value of 0.236, a z-score of 50.76, and a p-value less than 0.01. Next is results of map dengue cases and land use land cover. This map illustrates the relationship between dengue cases and land use land cover. Most dengue cases are concentrated within built-up urban and residential areas, while fewer cases are observed in forests, agricultural land, or water bodies. This map shows the spatial relationship between dengue cases and land surface temperature. Most dengue cases are located within areas experiencing relatively higher surface temperatures. Warmer environments accelerate mosquito development and increase the rate of virus replications, creating favorable conditions for dengue transmission. For discussions, overall the findings indicate that dengue cases in Pulau Pinang exhibit significant clustered spatial patterns rather than random distributions. The overlay analysis further demonstrates that these clusters are mainly associated with higher land surface temperature and built-up land cover. This suggests that warmer urban environments provide suitable conditions for mosquito breeding while increasing human exposure to mosquito bites. Therefore, integrating GIS, remote sensing, and spatial statistical analysis provides valuable information for identifying high-risk areas and supporting more effective dengue surveillance and vector control planning. In conclusion, this study successfully achieved both research objectives. Global Moist Eye confirmed that dengue cases in Pulau Pinang exhibit significant spatial clustering, while the spatial overlay analysis demonstrated that dengue clusters are mainly associated with higher land surface temperature and built-up land use land cover. These findings highlight the effectiveness of GIS and remote sensing in understanding dengue distribution and supporting evidence based on public health decision making. I think that is all from me. And with that, that concludes my presentation. Thank you very much for your attention. That is all from me. Thank you.